Welcome back to Miss
Bobby says, welcome back to Miss Smith, second period math class.
Welcome back, guys. Today we're going to be learning about writing exponential.
So, there we go. Andrew says today we're going to learn how to write exponential equations. So, we're going to look at mainly tables and word problems.
Yes.
Okay. So, maybe I'll die today. I don't know. All right. So, there are two things that I'm going to need you to be able to identify from a table or a word problem in order to write an exponential. Okay? The first thing you're going to need to identify is your initial value. If it's my initial value, how do I know that?
It's in front of the base.
Okay, but how do I find that from a table?
When
When your x is 0, this is your y-intercept. So your initial value is your y-intercept, and it's when x is 0. Okay, so you're going to have to identify that initial value. You're also going to have to identify what we call a base. What is my base value?
What's being times?
What's being multiplied? This is your multiplier. Okay, this is your multiplier. Okay, so if we can identify those two, all we do is fill them into this form, and your equation is done. Okay. So, let's take a look at this first example. What is my initial value here? 3. My initial value is this. What is my multiplier? What am I multiplying by each time? Times 3. So my multiplier is 3. So that means my equation is y equals 3 times 3 to the x. Ta-da! Okay. It's that easy from a table. That junk's hard. Oh, Seth. Muy difícil.
You tried.
I tried. You're right. I learned a long time ago when I took Spanish, I cannot roll my R's for anything. They tried. They tried so hard. I can't. No, I just can't. I sound like an idiot. I can't. It just doesn't happen. Do it for YouTube. All right. Flip it open. We're on the left-hand side. What is my y-intercept? -5. What is my multiplier? Remember, your multiplier always has to be a positive number. Why is it 1/5, TJ? Because it's technically what? It's technically dividing by 5. So 25 divided by 5 is 5. 5 divided by 5 is 1. Okay? Dividing by 5 is the same as multiplying by 1/5.
So -1 divided by 5 would be -0.2.
Yes, -1 divided by 5 is 0.2 because it's 1/5. 0.2 is the same thing as -1/5.
I know the equation. The equation is y equals -5 parentheses 1/5 x. Boy, I was talking.
Okay, you don't want to say 1/5 x. You want to say 1/5 raised to the x. 1/5 x is 1/5 with the x right beside it, which would make it a linear. So, I understood what you meant, but we're gonna work on being able to speak mathematically. Huh? There's a trash can right there.
Oh, it fell out.
Somebody kicked it. They kicked the bucket. Somebody kicked the bucket. All right, try this one on your own, and I'm gonna pick somebody.
Me. 12.
Me, I'll pay you. Look at that, Miss Mark. Hey,
I
right.
want more.
I will pass this class if you pick me.
If you pick me,
Listen, I'm hoping y'all pass this class.
let me do it. It's so easy.
I will come and
All right,
I'm
Amor, do this one for me. Y-intercept.
It's time for.
Shut up. I can do this. How do I write it out?
You can just tell me, and I can write it if you want.
Oh my God.
You left-handed?
Yo.
Good.
Smart.
Okay, so Amor says,
Did you put one on before two? Or no? No.
okay, are we ready? Because I'm not about to scream over you. Okay, so Amor says y-intercept is 12. Your multiplier is 4, which means your equation is y equals 12 times 4 to the x. Okay. And to answer your question, Maya, no, you cannot multiply by 1 over 4 because that means you would have been dividing by 4 as you go. Okay. But that is a very good
So if
question.
you're basically dividing, you just
Put it in the bottom, you put it in the denominator of the fraction, yep. Yep. Who's still, you want to do this one? Go.
That's literally the easiest one.
Or do you want to just say it? I can.
All
right.
It's the easiest one.
All right. Who still wants to do this one? What's my y-intercept? What's my multiplier, Husto? So my equation?
I get messed up on his part, on my part when it's like decimals and stuff.
Okay. So both of these equations that I wrote are exactly the same. When you're multiplying, when your y-intercept is a 1, I don't technically have to write it in the equation. Okay, so 2 raised to the x could just be your equation without that 1 written there. That 1 is understood. Okay, so Amor with the decimals, when it's 0.25 and stuff, I think about it this way. You've got a quarter, then 50 cents, so that's 2 quarters, and then $1.
Oh.
So you can see the pattern, 1 quarter, 2 quarters, 4 quarters. Okay.
All right, somebody can do the next one because I don't know. I asked.
All right. Oh, they said there's no 0. Alexis. How do you know that 0 is 432? Good. So Alexis says, as I'm going from 72 to 12 and 12 to 2, I'm dividing by 6 or multiplying by 1/6. So my multiplier is 1/6. So to work backwards, I would have to multiply by 6. And you said we get 432. So your 0 then, your y-intercept is 432. So y equals 432 times 1/6 raised to the x. Good.
Wow.
Oh, that didn't make sense at all.
What do you mean that didn't make sense at all?
I don't know.
Just like when we did linears. So let me put a linear up here. So 1, 2, 3, 4. So 12, 15, 18, 21. Okay, so Amor, if this was a linear, when we did this with linears, we said this is plus 3, this is plus 3, this is plus 3. So as I'm going down my chart, I'm adding 3. So to go in the opposite direction, we would subtract 3. Which means my 0 would be 9. 12 divided by 6 is 2. 2 divided by 6 is 1/3. So if I'm dividing as I'm going down my table, to go in reverse, the opposite of divide is to multiply. So to go backwards, I would multiply by 6 instead of dividing.
So you would subtract
12 minus 3 is 9.
So if you were subtracting down, it would add back up.
Yes. So, Savi just made a good point too. She said if my pattern was to subtract as I went down. So if we went from like 10 to 8 to 6 to 4, I'm subtracting by 2. So if I needed to work backwards, I would add 2. So 12, 14. Okay.
But you only have to find one, right?
The only reason we had to go backwards is because we had to find your y-intercept when x is 0 that your table didn't give you. All right. Brenda, you want to do this next one?
Oh, yes.
Okay. Shh.
The y-intercept is 6,
Good.
and you're multiplying by 3. Yeah, 2, not 3.
Ooh.
No. 'Cause look. 3 times.
It is 3. You're adding.
But 3 times.
Oh. Who just said that?
9, 10, 11.
All right. So we've got a problem. This is not exponential. This is linear. So I don't have a multiplier.
So why don't I have addition?
Actually, hold on. 6.
Yeah. So look, 3 plus 2 is
How
5.
is it linear if
3
this
plus
is
2 is 5.
exponential equations?
But
If you times it by 2,
Hey, you
3
can try
times
something
2 is
else
6,
in life.
right?
Hold on. There might be a multiplier here. Hold on.
Right.
It is multiplied.
You can't do it. Yeah, it's impossible.
Why? You know?
6.
3 times 6 is 6 and oh, wait.
No, it's just not exponential.
So is that a trick question or did they mess up?
Probably. Or they messed up. One or the other. So let's go with it was a trick question. Okay. Because your pattern here to start out with should have been multiplied by 2. But 6 times 2 should have given me 12. So this is technically linear. So this is not exponential. So your equation then should have been y equals 3x plus 6. Remember, it's y equals mx plus b, where b is your y-intercept and m is your slope or your pattern. Okay, so that's why the 3 went in front of the x and the 6 is your y-intercept. Isn't this the one I put on the board yesterday for the warm-up that I messed up?
And then you put it on.
And then I fixed it?
You put it on our little
Yeah,
quiz thing or whatever.
I stole it.
On the graph.
Oh, that's all.
Okay,
Yes, it is.
so yes, this one is decay. What is my y-intercept in this picture?
2.
2.
I was freaking 12.
It's where it crosses your y-axis. This is 0, so 1, 2.
Oh, never mind. We'll go with,
Okay, good. So, Xavier said my asymptote
It's 0, right?
is 0. It's y equals 0. Okay, so we need to find my multiplier. So we need to compare my y values. So here my y value was 4, here it's 2, and here it's 1. So what's my multiplier?
6, 2,
But what am I doing with 2? Left to right.
Oh, you.
I'm dividing by 2. So my multiplier is 1/2. Okay. You can also put
so then it's y equals.
0.5. So y equals 2 times 0.5 or 1/2 raised to the x.
You're done.
I think the division was going.
Yeah, in the graph.
Your biggest thing is going to have to be paying attention to when you divide. Maya said that's going to be something she's going to struggle with. And reading the graph from left to right. Okay? Just like you read a book. Because if you read it from right to left, you're actually multiplying by 2 instead of dividing. So you have to be careful. Okay. I need you to find this piece that we cut out. Okay, this is a flow chart that will walk you through your word problems. So if you use these questions to do your word problems, this will help. So it says a $15,000 car will depreciate. What does that mean? Go down, depreciate, decline. Okay, all of those words mean go down. So we're depreciating 25% annually if kept in good condition. So what did you say? Every year. Annually means every year. Okay. Write an exponential function that would represent what the car is worth after X years. How many of you have heard of Kelly Blue Book?
What the?
Which gives you the value of your car.
That commercial.
Yeah, that.
Guess what? They use this. This is how they come up with your values of your car after so many years. Cool, math in the real world. Believe it or not. Okay? So, they want to know, the first thing you have to identify from your word problem, what is your beginning amount? 15,000. Okay. What is the rate? And they want you to write it as a decimal. 0.25. Okay. So whatever your percentage is, remember your decimal is right here. We move it 1, 2 spaces to the left, and that becomes your decimal form. Okay, so take your rate, write it as a decimal. Then you need to decide, is my car value increasing or decreasing? It's decreasing. So, will the car's worth increase? Your answer is a no. So we move over to here. 1 minus the rate that you had. So 1 minus 0.25. What's 1 minus 0.25?
Negative.
0.75.
0.75.
Period.
No. Okay. So now you have all of your pieces. My initial value you told me was 15,000. My factor is that 0.75 that you just got raised to the x. You're done.
See, I would like if it was like this, if they like.
They're not going to do that on your test, though. What, bam?
So the car costs $75?
No. So, what this is telling you, so
You multiply.
let's say the 2 years have gone past. Okay? So, 15,000 times 0.75 and 2 years have gone past. So, you would plug this into your calculator. Who's got a calculator on this? Plug this in. 15,000 times 0.75 raised to the second.
$842 ain't cost him.
840. Really? That low?
Yeah.
Wait,
Wow.
so we went from 15K.
You know, you only put in 1,500. I was like, dang, that's really low. 840,
It'd be
$8,437.50.
It still went down a lot.
It did, but not as low. He wanted to do like freaking $843. Okay, so what this equation tells you is if you keep your car in good condition, if you bought it at 15,000, in 2 years you should be able to sell your car for $8,437.50.
So is that mean keep your stock? You don't add no everything to it?
Now, that's not saying did you add stuff to it. Of course, if you make it better, you're going to be able to charge more. This is just you get your car, you make sure it's clean, you don't get stains in it, you don't smoke in it, you don't do any of that stuff. You can sell it at a good price. My husband, and I yell at him all the time.
Let him smoke.
Cigarettes. Smoke Marlboro.
Okay, so let's review from an equation. F of x equals 2 times 2/3 raised to the x. What's my initial value in this equation? 2. What's my factor or my base? 2 over 3. Is this growth or decay? Why?
It's less than 1.
2/3 is less than 1. Okay. So my initial value was 2. My factor was 2/3. We know it's decay because 2/3 is less than 1.
So, do you go by your top number?
What do you mean?
Like,
To do the growth or decay?
yeah.
So if you struggle with fractions with growth and decay, I would change 2/3 to a decimal. So I would literally in your calculator, 2 divided by 3, and you get 0.6 repeating. 0.6 is less than 1. Because sometimes you have an easier time comparing decimals.
That's number 6.
So if it was 6, it's growth. If it's 1.5, it's growth. If it's 1.1, it's growth. But anything like 0.9, even 0.999 is decay. It's decaying very slowly, but it's still less than 1, it's still decaying.
So is there a amount in this instance?
I would not. Okay, so all those steps that we just did on that flow chart are repeated here on the right-hand side. So you've got it twice now. So I don't want to hear, I don't have steps, I don't know how to do this. Gave it to you twice. Okay, open it up if you had it folded. If you didn't have it folded, just turn it over. We've got 2 examples to do. Easy peasy lemon squeezy. Okay, so the grain stored in a grain elevator decreases at a rate of 5% per week. The amount in the grain elevator today is 80,000 cubic meters. What function could be used to represent this situation? So what's my beginning amount of grain?
80,000.
80,000.
liters.
Are we increasing or decreasing? Decreasing. So if we're decreasing, that means I do 1 minus my rate. Well, my rate is 5%. So that means 0.05 as a decimal. Again, your decimal point is here. We move it 2 spaces to the left. Because there's nothing there, we fill it in with a 0. No. 0.5 would be 50%, not 5%. Okay? If you struggle with just moving the decimal, if you take your percentage and divide by 100, you get 0.05. So you can always take your percentage and divide by 100 to get your rate. Okay? So if that works better, that's fine. So what is 1 minus 0.05? 0.95. Like 95 cents. We're getting rid of a nickel. So my function then is y equals 80,000 times 0.95 raised to the x. Huh? I don't know.
Look, can you do like a song?
Questions on that one? Okay. Let's try this one without any steps. So, Sabi says my initial value is 5,000. Okay, so we're increasing by 5%, which is what is a decimal? 0.05. So to get my factor, because I'm increasing, it's 1 plus 0.05. So 1.05.
And then y equals 5,000 multiplied.
1.05 raised to the x. Yes.
I really have to pee, but I'm gonna work. Still?
Well, we just finished notes, so Sabi asked first, so as soon as she comes back, Amor, you may go. Okay, so this one is kind of like a booklet. We did. You are supposed to fold it so you can still see the writing exponential functions. So you're supposed to fold it so it looks like this. It is. Huh? I'm supposed to deny it? Just think we're only on unit 3. We still got unit 4, 5, and 6. Okay, so on page 74, you should glue in that first one. On page 75 is this one. And on page 76 is that last one. And you'll lose points later.
Y'all know something.